Okay, previously we discussed um, regarding force, friction force, dry friction, and about the three cases of sliding: the static case, the impending sliding, and the dynamic case. Now, on those examples, we have not considered what you call tipping. Tipping. When you say tipping, it's like overturning. Okay. Now, what we consider is, for example, we have this jar right here. Okay. So, as you can see with this jar, okay, if I will simply push it, okay, with a certain amount of force, it will slide, it will move. But we have not considered the possibility of tipping or overturning. Kasi pag, if I am just going to apply force at this location or somewhere at the middle of the height of this jar, it will simply slide. But what if I am going to apply the force here? And then I will push. And as you can see, it may not have it may not have slid or glide, but it actually is tipping or overturning. Okay, so what this is what we have not considered during our last examples. And now we will consider the possibility of tipping, and one of the factors is the location of the force applied on the object. Okay, to illustrate, okay, we will now consider this homogeneous block that is placed on a horizontal plane surface. Okay, now given all the dimensions of the block and the position of force P, okay, again with with its contact with the horizontal surface, then there will be two forces developed. You have the normal force and friction force if the surface is rough. So as you can see here, the normal force is not directly on the direction of the weight, because normally if we don't have external forces applied and we have this simple system with its weight, the normal force is just in line with the weight. Now, um, uh, there are times that it's not directly on the action of the weight. It's rather on a certain distance from the center of gravity. Okay. Now, depending on the magnitude of P, depending on its location, what location, what was it applied, what on what certain height was it applied, would be where the normal force, the position of the normal force on the plane of contact depends. Okay. Now, this is the idea. If normal force, okay, we have here P. If normal force is found to be exactly on the corner of possible tipping, kasi kung titingnan mo dito, if we will apply this force, it will possibly tip on this corner. Possible siya na dito siya mag-overturn. Okay? Because if it will tip, this is the corner, or this is the corner of the object where possible tipping may occur. So, if this normal force is exactly on the corner of possible tipping, then this means that it is impending tipping, meaning it's already on the verge of tipping. It's not yet tipping, it will not yet tip, but it's already on the verge of tipping. So, if during our equation or solution, we found out that normal force is way outside of the plane of contact, okay, and beyond the corner of tipping, then we could say that it's already tipping on that point. So, for example, we solved this system, then and we found out that normal force actually acts outside of the contact area and beyond the corner of tipping. Then this situation is when tipping occurred or occurs. Okay, so that is how we could analyze if the object is tipping. Okay, now on our previous examples, we considered only the possibility of sliding, whether it is sliding or not. That would give us the conclusion as to whether or not it is on static case, impending sliding, or dynamic case. But what we did not consider is the impending tipping, or the possibility of tipping, whether it tips or not. So when we talk about equilibrium, we should both consider whether or not it slides on and whether or not it tips. Okay. Let's have an example. This man, as you can see, it is pushing the crate. Okay, and the crate has its own dimensions. Now, this force P, the force P that is the pushing force of the man on the crate, is on the height of 0.9 meters from the ground. Okay, but the actual total height of the crate is 1.8, as you can see here, and the width is 0.6. Now, the man is trying to move a packing crate across the floor by applying a horizontal force P, which is this one, exerted by his arms. The center of gravity of the 250 Newton crate, so this crate actually weighs 250 newtons, is located at geometric center. When you say the geometric center, this is the crate, and its weight just simply is applied or acting on its geometric center, or its center geometrically. So basically, this is just a simple rectangle, so the geometric center is simply here at the center, half of the width and half of the height. Does the crate move if P is equal to 60 newtons? The coefficient of static friction between the crate and the floor is 0.3. So this is the contact surface. So it was said in the problem that mu s is equal to 0.3. Now, let's redraw. Okay, so the man, this is the crate. Given dimensions, we have 0.6 by 0.8. It's a total height, 0.8. Or rather, 1.8. Sorry. Let me just correct that. Okay. Now, the pushing force of the man is applied at a certain height of 0.9 meters from the ground. Okay. Yan. Okay. Then mu s again is 0.3. Now, it is given that P is equal to 60 newtons, and then the weight of the crate, which acts on the geometric center, is actually 250 newtons. So this is already the weight. We don't have to multiply it to gravity. If the given weight is mass or in kilograms, then that's the time we have to multiply it first with the gravity. Okay. Next. Our question here is, does the crate move? When it's asking for the movement, whether if it moves or not, two things we have to check. Is it sliding, and is it tipping? Okay. Now, with the question, is it sliding? It's when we compare FF actual with maximum static friction. So, consider initially assuming that it is static, we solve for the normal and friction force. So we have the normal force on the crate. That's of course perpendicular to the surface, and we have friction force. Friction force obviously is opposing the direction of possible movement due to force P. So, fill sum of forces Y, normal force, no other than no other forces, vertical forces, but the weight and the normal force is simply equal to the weight of the crate. Okay, now next is we will solve for the actual friction force on a static case. So friction force, as you can see, no other horizontal forces but only F, and P. So that is simply equal to P. And given that P is 60, so friction force is also 60. Well, let's check first if it's really static. So we will compare that to F maximum. And that is mu s times normal force. So mu s is given to be 0.3. And then the normal force is 250. So that F maximum, we have 0.3 times 250. That's 75. Okay, 75. Okay, we now compare the F maximum and the actual friction force on a static case. So we have found this is 60 newtons, this is 75 newtons. Actual friction force on a static case is less than maximum static friction. Therefore, it's not sliding. If it's equal, it's impending, still at rest, because when you say impending, it's like it's only on the verge, but it's not still actually moving. Okay, so it's not sliding. Okay, next is it tipping? There's also a possibility that it's tipping. So now, this is when we consider the tipping corner. Okay, this is the center of gravity of the crate. That's 250 newtons. This is 60 P. Okay, let's just assume that normal force is somewhere in between the tipping corner. So let's say the tipping corner is point A and the centroidal y-axis of the crate. So let's say NF is here. Okay, now it is tipping if NF is on the tipping corner. So this is our X maximum. Okay, this is a maximum placement of position of normal force from the centroidal gravity, center of gravity, wherein it's still not tipping, but it's impending tipping. But if it's within the plane of contact, not beyond the corner of tipping, then it's not tipping. But if the value of X, okay, the measurement of X is from the center of gravity to NF. If X is less than X max, meaning normal force is only acting within the contact area, not beyond tipping corner, so it's still not tipping. Again, if it acts right exactly at the tipping corner, then it's impending tipping. And if tipping is impending, then it's still at rest. But if we found out that the value of X is greater than X maximum, meaning normal force is like acting here, which is not possible, we could say that it's already tipping. So let's check what we have to do. In tipping, we compare actual X with X maximum. What do? We sum up moment on the tipping corner, and the tipping corner here is point A. Okay, positive. So that again, this is 0.9 meters given in the problem. Okay, so 60 times 0.9, then the weight, negative 250 times, okay, so this is 0.6, so therefore this is half 0.3. Okay, so we have 0.3. And then for the normal force, moment about A is clockwise, so that is positive. Normal force is 250, and the perpendicular distance to A is X max would be half of 0.6, and that is 0.3. So that X distance of normal force about A would be 0.3 minus x. So we'll have 0.3 minus x. What else? Friction force. Okay. Friction force is parallel to the plane of contact, so it would intersect the tipping point. So friction force does not have moment about point A. So this is not all in all equal to 0. Okay. Let's check the value of 60 times 0.9, 250 times minus 250 times 0.3, and then plus 250 0.3 minus x equals 0. The value of x is 0.303. Oh, we have a technical error. It should be minus instead of divided by. So anyway, its x is actual value of x is only 0.216. It's less than x maximum, meaning the placement of the location of NF, it's all located only within the area of contact surface, and it's not beyond the tipping point. It's not even on the tipping point, so it's not tipping. So it's both not tipping and not sliding, therefore it is static. Okay, and that was what this says. Does the crate move? It's static. It does not. The crate does not move. This is your conclusion. So the concept of tipping, if the tipping point is located only within the area of contact, then there's no tipping. But if it's exactly at the position of the tipping corner, it's impending tipping. But if on the solution we have found out that it acts away or out of the contact area and beyond the tipping point, then tipping already occurs. Okay. And okay. I guess we will continue this example on our next meeting.